Welcome to the next video in the systems programming video series. In this video, we'll move on to the second part of, what is this, I guess, assignment 5, yeah. And in this, we will be implementing binary char. Implement a program that asks the user for an 8-bit binary number and outputs the corresponding char. So making is as usual. You simply run and the program prompts for an 8-bit number, basically. So that's presumably, maybe there are other ways to do this, but I assume that basically gets read in as a string. And then we process that string until we figure out, basically the corresponding char. So we have a couple examples to see that we're doing things right. Let's look at the requirements hint. You can assume that the user only enters an 8-bit binary number. Okay, so let's come over here, binary char. Here is the implementation. It's a very small program, so this should be a pretty short video, I hope. We're going to prompt the user for an input. So I need to have a string ready to receive the input. I'm going to give it only the size of 8 letters, which is to say malloc 9 char addresses. Prompt the user, being rather terse. Okay, so we now have in this variable I've called binary, the binary number as a string, and then we want to process it until we get the binary representation. Now, I could do this within, I think, like an unsigned int, maybe even a signed int. Yeah, I think so. But in any case, ints are 4 bytes, but this is an 8-bit number that should, in principle, only require 1 byte. Now, okay, 4 bytes, 1 byte, these are tiny differences. And even if you scaled this thing up, I mean, the multiple of space that you're using is around 4, depending on what else is going on in your program. Any case, so like, I don't, maybe you're like, why not just use an int? But I figure it's good to just make sure that we know how to use these other types. So I'm going to work with an unsigned char. I think in most C compilers, char is by default unsigned, but I'm just going to specify unsigned just in case. Just in case some hardware uses signed integers to represent char values or something like that. So in any case, that's how I'm going to initialize things, right? So it's an unsigned char, which basically just means that like I can reason about the bitwise operations in a simpler manner, perhaps. And I'm initializing it to 0 because, in some sense, that's kind of like making it all blank to begin with, and then I'll populate it with its bits soon. So, okay, now I want to iterate through my string, looking at the bits in the string and using them to update or adjust the bits in this unsigned char C. Then a question is, how exactly are we going to do that? And should I traverse the string from left to right or right to left? It sort of depends on how you want to approach this. I think there's an approach in both ways. Yeah, and I think there's a relatively good approach in both ways. But since a lot of this section has been about the the bits, the addresses, so on. I figured that maybe it made the most sense, or maybe even in some way the intended style of solution is to work with bit shifts and bitwise operations, basically. So that's what I tried to do. And so if I think about how to do this in a bitwise operation, well, it makes sense to me that I would basically look at the leftmost char of the string and say, okay, first of all, everything starts at 0. I'm going to bit shift to the left by 1 on every iteration of this for loop. So initially, when it's all zeros, you bit shift to the left by 1 for a byte that's all zeros. Well, nothing happens, right? Because like the leftmost 0 kind of, falls off, but on the right end, you put a 0 on. And so it's all ready. You just go from a byte of all zeros to another byte of all zeros. So left shifting the first time doesn't do anything, but you'll see in a minute where I want this left shift at the start of each for loop. Okay, so anyway, the idea is take your initial all zeros, left shift by 1, then check to see whether or not the leftmost digit of the input string is a 1. If it's a 1, then put a 1 at the rightmost end of your unsigned char C. So, and effectively what I'm going to, it's almost kind of like taking that leftmost 1 in the input and writing it first, so to speak. And then I'm going to left shift everything and take the next character in the input string. And if it's a 1, I'm going to write a 1 at the rightmost position and left shift and write, and write, W-R-I-T-E, right? So left shift, let's say draw the bit, left shift draw, left shift draw until the whole thing is drawn out and you have exactly the, represented in your address in memory, the exact same binary number that was entered as a string. I hope that makes sense. So let's get into it. So if I say, okay, so I'm going to progress through the string from left to right, which is not necessarily always how you do it when you're working in binary, but that's the way I've chosen to structure this. So we're going to progress through the string, and I'm going to say that I'm going to left shift to begin with. So C is C left by 1, always, at the beginning of each iteration. And then I want to check to see whether or not the current char in the input string is a 1. If it's a 0, I don't do anything. But if it's a 1, then I want to add a 1 into my unsigned char C. So if binary at I is the char 1, then I want to update C by ORing it bitwise with the number 1, right? Because the number 1 is going to be all zeros except in the rightmost coordinate or bit, the number 1. So everywhere in C up to the rightmost bit, I'm basically ORing it with zeros, which means that if C had a 0 there, then the result is 0. If C had a 1 there, then the result is 1. That's, sort of how this bitwise OR is going to work when you're bitwise ORing with zeros, basically. So up to the last bit, I'm ORing with zeros, which basically just makes this kind of copy all of what C already had, whether it was a 0 or 1. Then, in the rightmost bit, because I am ORing it with 1, that's forcing the rightmost bit to be a 1, which is, in a sense, kind of like just writing a 1 in the rightmost bit and keeping everything else the same. That's the basic logic of what I've written here. If it's a 0, I don't make any changes. Is there anything else to do? I guess, and I probably should, just out of habit, say if bang binary. Whatever I malloc, I should free. So let's free binary, null the pointer, return 0. So I think that might be everything for the for loop. And then at the very end of the for loop, I want to print the char that I accumulated in this variable. So I'm not sure there's anything else I need to consider. Yeah, let's try it. Okay. Okay, looks good. Prompts me for an input. Let's come back over to here, check, or let's just use this test input. So come back over to here, paste it in, and we get the char A. Very nice. Let's do it again. Copy the other thing to test. And it's exactly right. Oh yeah, I guess I meant to, okay, I'd like maybe put a little bit more description of what's going on in the little output, but whatever, that's fine. It's working, so end of video.